In this lecture, we are going to discuss about the data acquisition system and its implementation in LabVIEW, which is a software predominantly used in industries. So data acquisition is done by DAQ assistant in LabVIEW environment. So we know data acquisition is a process of measuring physical signals and converting them into digital data. So real world situation have physical signals in the form of temperature, pressure, voltage, speed, and more processes are running around us. So these are the sample physical signals which has to be converted into a equivalent digital data for making a data acquisition system works. So DAC will bridge these real world signals to the computer process as in this figure. So here the physical signals are available in the left hand side where your signal may be analog, digital or a sensor signal which is of combined of any kind of data. So that will be read by a card which is termed as data acquisition card. There you are providing digital inputs and outputs, analog inputs and outputs, and they will be provided as a processed signal for your application uh, program interface. Here, a software will be equipped that will process this data and show the uh, processes and its variations in a exclusive application. So a DAC will have the following components. So it is a process which convert the physical signal into digital data. It also includes sensors, transducers, where sensor is a thing which convert physical signal into another physical signal. Transducer will convert physical signal into a electrical equivalent signal, and those signals has to be processed for making the signal ready to be converted into a digital signal. And once the digital signal is ready, then your hardware, DAC hardware, will convert the data into uh, computer readable computer readable information, and that will be available in LabVIEW. So the diagram oriented representation is here. So your physical signal may provide a signal like this, which includes noises, external noises and all, and that has to be processed inside your data acquisition system. And the converted analog to digital conversion will make the signal, analog signal into a digital signal conversion, and your system will take digital data for processing the further information. So what is LabVIEW? LabVIEW is a graphical programming environment which is manufactured or which is developed by National Instruments. Now it is Emerson's uh, product, and this LabVIEW's work is to make a system, PC, which is able to provide the real-time monitoring of the system parameters. It is done by G programming languages, which is a data flow programming. It uses blocks, and that blocks will have a powerful data structures and their data sets also, data types also. So it includes two windows, one with the front panel and another with the back end, which is nothing but the block diagram. Here, the developers will do block diagram based logical programming, and those blocks will be represented in the front panel as a uh, application program interface. So the features of LabVIEW includes real-time data visualization, easy hardware integration, and drop drag and drop programming. Drag and drop in the sense in MATLAB you have Simulink, where you can take a block and put it into the programming language where you can use it very easily. So such things are already developed in LabVIEW some 50 years back. So LabVIEW environment will have a structure like this, as we mentioned earlier, we have one front panel and another one is a block diagram. See, every component in this block diagram is accessible for engineers, and this block diagram will be represented here as a front panel component. So this front panel component is used for the user interface. See, numeric 2 is the two inputs. Here the numeric and numeric 2 is there. So numerical data will be provided by this particular input. And also Boolean kind of inputs will be provided, either on or off kind of switching action will be provided in this block. So the pair will be available in block diagram and uh, and front panel. So data acquisition system is the one which collect data from the external world, and it will be processed by this particular LabVIEW environment. And of course, here there is a loop where you have a while loop which process this data again and again, and the process will have a process delay for avoiding data sample mismatches. And data acquisition in LabVIEW will be processed based on this particular diagram. So your physical signals are available, and those signals are in the any kind of format, and it will be processed in the signal conditioner. After processing, you are collecting the data to your DAC, and that DAC may be of PCI DAC, or it may be of your Ethernet connected wireless DAC. So those DAGs will collect these data and it will be processed by a programmable logic controller. So PCL, and which will be processed here for making switching actions or either monitoring actions. It will also do data logging kind of things, and it will do application program interface where data will be controlled. That is, data will be visualized, and the control signals can be provided by the PC itself. Not a person need to go into the real field. And your data acquisition system architecture will have this outline, and it is having this kind of internal structure. So this block is NI9208, which is an IO card where analog inputs are available here. See, analog inputs with the 0 to 15 are available, and these analog inputs can be single-ended or that is double-ended. And here your analog input will be multiplexed by the multiplexer. So a particular time will be provided to read this particular port, and that will be amplified, and it is provided as a ADC data with the isolation. So that is how every analog input will be isolated, and it is provided to the PC for better processing accuracy. So this is the specialty of LabVIEW card, IO cards, and this is one of the analog input cards. And DAC assist is the one which is providing these kind of facilities, where Express VI is nothing but the visual instrumentation, where it configure your data acquisition system with selection of channels, sample rate, and the process running capabilities. So you can control the sampling rate for better visualization of the signal. See, a data assistant is configured here in the block diagram, where the data is visualized in a chart, waveform chart. Here, amplitude and time is there. One more information is that here the time will be logged here with the event log. So LabVIEW can provide not only data visualization but also data logging kind of things, and that is provided by the use of this DAC assist, which is a block can provide more information. So data assistant is an express VI used for quick configurations. So it is a plug and play kind of thing. Once it is plugged, then it will be configured automatically and collect the data from the external world and provide information to the PC. So it allows channel selection, sampling rate selection, and input type selection. So whatever be the things, you can either provide voltage signal or current signal. That also it can be of digital kind or analog kind. Whatever be the thing, it will be processed by your data assistant, and the steps involved in the processing is here. So you can have to add the data assistant into the LabVIEW environment, and you have to select the input type, and you configure the sampling rate and run it. So it is a very simple process of making data acquisition live. And here, waveform visualization in your LabVIEW. As we see early, so LabVIEW will have front panel and a block diagram window. So these two are the separate windows where here you can program your waveform visualization. See, a data assistant is here, which provide the data which is available in the external world as a waveform. And of course, it is visualized in a thermometer format. So both are showing the same data. So the waveform chart provides information with respect to time. See here, the date time will be logged here, and the sampling time will be set by us. Either you can visualize the data as like this, or you can visualize the data as like this. So the both provisions are provided by LabVIEW, and all put together in a block diagram as a loop. So this process will be running again and again, and the process delay will be provided for avoiding the losses. And here, as usual, we have numeric, Boolean, and different kinds of data types available for representing the waveform. In LabVIEW, there are two kinds of waveform representations available. One is graph, another one is chart. In graph, you have static data which can be visualized, but in chart, you can have a running or streaming data which can be represented. Also, in graph, you have two axes. One is x and y axis representation. But in chart, everything will be logged with respect to time. Every process parameters like voltage or your temperature, whatever the thing. So these two kinds of waveform representations are available in LabVIEW. In LabVIEW, there are different kinds of data types available, and it is for supporting the different parameters which it handles for processing the data acquisition. So numerical informations are handled separately as a separate data type, as in the figure. See, numericals are in a blue color representation. Also, it can be either as a double kind of representation where orange colors are used, that I will show. And Boolean structures are represented as a green color. So here you can visualize these color differences, and you can understand which kind of data are being traveled. Similarly, strings are also a data types which are rose color, where this color indicates which data is flowing from which position to which position. Such informations are easy in LabVIEW programming. And data types in the LabVIEW are visualized in this particular structure. See, as I mentioned earlier, orange color represents numerical data, blue color also represents the numerical data, but orange color is nothing but the double precision number, and integer represents only positive number. So positive as well as negative number is here, only positive number is available here. In Boolean data, it processes either true or false with the zeros and ones as the input. So it is a separate story, and the strings provides the information about message signals. And here is the array. See, array is the collection of data which either be as a numerical or Boolean or string. So such facilities are available in a cluster. That cluster is nothing but a data type which provides combinations of things. So in numerical data also, you can process only scalars, or you can do one dimensional array, or multi-dimensional arrays are also possibly handled. So such quality data types are supported by LabVIEW. And here it's another representation of the same thing where arrays and clusters are most vital things. So here the cluster is nothing but a different grouping of different data types, which is not possible in many softwares where array is a collection of same data and cluster is a collection of different data types. So this slide shows the same thing in a different flavor. So orange color indicates floating point representations, blue color represents integers, green represents boolean, and pink represents a string, and this block represents the array where numerical data are stored here, and this block represents that is the brown color shade represents the cluster, which indicates different types of data are handled by a single block. And this is the front panel representation. See, the array of numbers, numericals are showed here. 1, 2, 3, 4 are the numbers, are the data stored in the particular location. If you want, you can take these data as per the requirement. So every data will have an identity, and you can mention it and take this data for use. And similarly, waveform data types are a particular uh, special type of cluster where it starts with the T0 signal and it has the sampling rate as we mentioned earlier, and your output signal Y will be a signal which is visualized in your graphical record. So waveform is one of the cluster data. And practically the LabVIEW environment supports these kinds of temperature visualization. See, this is the block diagram and this is the front panel where a temperature data is visualized um, as an indication here. So the data will be visualized as a waveform here. So in LabVIEW, you can visualize a particular data in either graphical format or as a indication level format. So applications of LabVIEW will be available now in industrial automations, biomedical monitoring, robotics, smart agriculture, and signal processing kind of things. And the DAQ-enabled real-time data acquisition is a vital thing in LabVIEW, and the LabVIEW provides simplified programming, and waveform is essential for signal analysis, which is also provided by LabVIEW, and the data types are the important thing which supports the waveform visualization, which is a rich set in LabVIEW. So those things are the takeaways from this video. Thank you.